Hey everybody, hope everybody's doing well. This is going to be the tutorial video for section 12.5. We're still talking about circles, but what we're going to do today is we're going to look at circles on the coordinate plane, so on the x and y axes, which we haven't done yet. Okay, so time to take a trip to the coordinate plane. Part of what I'm going to do at the beginning is going to use Desmos, so if you take a look, I'm going to present my screen to you for a minute. If you open up the Google Doc that I sent you for this week, give it a second. There we go. If you go to Tuesday, which is for you guys today, I'm making this earlier than Tuesday, but we're at Tuesday 512 right now. One of the first things you should see here is something that says Circles Desmos slider for HK and R values. Open that up so that when I'm going through something at the beginning on Desmos, you can kind of play around with it as I play around with it. You'll see there's a nice little circle graph, and we're going to talk about what the H, the K, and the R values mean. Okay, so have that open. We're going to go from that to the notes. All right, so I'm going to hide my camera, and you'll still hear my voice. Okay, so just kind of goals for today, what we're going to do is we're going to be looking at circles on the coordinate plane. If I give you the equation of a circle, you should be able to graph that circle. If I give you the graph of a circle, you should be able to write the equation of that circle. And other types of problems will involve giving you specific pieces of information and being able to write the equation of that circle. Okay, so that's kind of where we're going for today. So the first thing I want to do is I want to start with the Desmos graph. Okay. And you'll notice I have this kind of funky looking equation, x minus h squared plus y minus k squared equals r squared. This is the standard form of a circle on the coordinate plane. This is how we produce a circle on the x and y axes. You know, kind of like for lines, how we had y equals mx plus b, or for parabolas, we have y equals ax squared plus bx plus c. Every function has its own type of standard form, even though this isn't really a function. It doesn't pass the vertical line test. But I should say every shape is going to have its own unique equation on the coordinate plane. And this is the equation for a circle. There's three values I want us to take a look at right now. One of them is the h value, one of them is the k value, and one of them is the r value. And every single one of those controls something special about the circle, whether we move it up and down, left and right, make it get bigger, make it get smaller. So what I want you to do before you play around with it, take a prediction. What do you think the h value is going to affect? Notice it's next to the x, and the k is next to the y. Think about what do you think the h value might change if I was to change that value on the circle? So put a guess in your head, and then we're going to test it. So right now, h is set to 1. Let's just say I start moving it around. If you notice, the circle starts moving left and right. So what this is doing is it's moving the circle left and right, and more specifically, I'm going to set it back to 1 for a minute. If you click on the dot in the center, which you should be able to do if you have this open on your tab, notice it says that that's the coordinate of the center is at 1, 1, and the h value is set to 1 now. Let's say I just move this to 2. Notice how the x value of the center, changes to, if you hover over it and click, is now at 2. So really all you're doing is you're changing where the center is located. This changes the x value of the center. Now I have it at 6. Now it's at 6. Likewise, if you look at the k value, it's next to the letter y. Y moves things up and down. So we would expect this to change the y value of the center. Right now, you'll notice the y value is at 1. Oh my goodness, it's going up into the air. Now it's at 3.1. Click on the dot. It's at 3.1. Go up to, let k be 5. Now your center's at 6, 5, because I changed the k value to 5. Now you'll notice if you put it in the equation, though, what's going to happen is you're going to see a minus 5, because look at what's next to that k value. You got a minus sign. So everything that's related to the center, if your center's at 6, 5, when you go to plug it into the equation, you're going to see a minus 6 and you're going to see a minus 5. Whatever the coordinate is here is going to be the opposite sign when you put it in the equation. So if I want my k value to be negative, let's say I want it to be -2. So now it goes down to -2. Even though the center's coordinate is at 6, -2, I'm going to see a -6 in the equation, but I'm going to see a +2 because I'm going to be subtracting a -2. So just keep in mind that your signs need to change. And the letter R, you could probably guess, stands for the radius. Right now I have it set to 1. If you click on the top of the circle, the left of the circle, oh, does it let you do it? Maybe the left, it doesn't work. At least the top and bottom, you can count from 6, -2 to 6, -1 is a 1 unit distance, and from 6, -2 to 6, -3 is a 1 unit distance. So that radius is 1. And you'll notice in the equation, though, it's not r, it's r squared. So it's squaring the radius in the equation. If I change my radius to, say, you go to 9, this is pretty big. I'm going to have to zoom out a little bit so I can see this. If you want to zoom out, just go to the little minus sign in the top right corner. Here's the center at 6, -2, and then if I go to the top of the circle, it's at 6, 7. From 6, 7 to 6, -2 is a 9 unit gap, because all you're doing is changing the y value from 7 to -2. So the radius, the distance from the center to that point on the circle, is 9. But notice in the equation, when you type it in for r squared, you're not going to see a 9 on the right side of that equal sign. You're going to see an 81. So it's important that you square that radius. Okay, so just to summarize, HK is your center, and R is your radius. And that's really all you need to graph a circle. I'm going to switch out of Desmos now. I'm going to go over to our handout. Okay, and let's explore some circles a little bit more. And these will come back up again in Algebra 2 and in Pre-Calc, but we give you a little bit of an introduction to circles on the coordinate plane this year. So just like we saw in Desmos, the equation of the circle is determined by the center and determined by the radius. So it's x minus h squared plus y minus k squared equals r squared. H comma k, that's the center of your circle. And r is the radius of the circle. And again, notice in the equation it's r squared, so you got to make sure you square that radius if you're writing the equation. And the other thing you need to be careful with is those minus signs. Whatever shows up here, you got to switch the signs when you put it in the equation. So for example, let's say they want you to write the equation of a circle with a center at 3, -5, and the radius of the circle is 6 centimeters. What do you need? You need h, you need k, and you need r. The center is h, k, and the radius they're telling us is 6. So if you look at your format of your equation, you need x minus h squared. I see a positive 3 for h, which means I'm going to have to make it x minus 3 squared. Plus, now I look at the y value of the center. I see a -5 for k, which means when I do minus -5, now I'm going to have y plus 5. All I do is change the sign on that k value, squared, equals, and we're not putting 6 on the right side, it's the radius squared. So I'm going to take 6 and square it, and I'm going to put 36 on this side. And that's it. If you were to graph that on Desmos, or even by hand, I'll show you how to graph one after by hand, you would have a circle with a center at 3, -5, and the radius would be 6. Let's look at a different one. Write the equation of a circle that passes through the origin. Okay. And really, you know what, let's cross this off. This should say with a center at the origin, I'm sorry. Passing through would be different. Passing through would be if the origin was on the circumference of the circle. We want this to be at the center. Okay, so we want the equation of a circle with a center at the origin, and the diameter, not the radius, the diameter is 4 rad 6. What do we need before we can write the equation? We need to know the center, hk, and we need to know what the radius is. Well, the origin, I know right away, is 0, 0. So this is my h, this is my k. And the diameter, remember, is 2 times the radius. So if the diameter is 4 rad 6, all I'm going to do is I'm just going to divide that by 2. And so my radius would be 2 rad 6. I just cut the outside number in half, not the inside number. So now, okay, when I write the equation, I don't want r, I want r squared. So I got to take my 2 rad 6, and I'm going to square it, which means I've got to square the 2, which is 4. And if you square the rad 6, you just get a normal 6. So my radius squared is 24. So now putting it together, you have x minus 0 squared plus y minus 0 squared equals 24. And you want to simplify this. The one I did up here, there's nothing else to simplify, but here, what is x minus 0? X minus 0 is just x. So I get x squared plus, what's y minus 0? If I have y and I take away nothing, I still have y squared equals 24. And Math Excel is going to be picky about that. Don't type in x minus 0. They're not going to consider it simplified. Okay. So just x squared plus y squared equals 24 would be the equation of your circle. Here's the first one. Here's the second one. Here's one where they give you the equation and you have to produce the graph yourself. So first of all, let me get rid of some of these random dots. Those are actually not going to be on our circle. Graph the circle, x plus 2 squared plus y minus 4 squared equals 25. What do we need to graph the circle? We need to know what the center is, and we need to know what the radius is. The center is related to these two values you see here, but you have to change the sign. If you see a positive 2 here, really means that the x value is negative 2. If you see a minus 4 here, it really means the y value is positive 4. So my center is at negative 2, 4. Remember, this one over here is r squared. That's not the radius. That's the radius squared. So if the radius squared is 25, you've got to square root it in order to get the radius back out of that. So my radius would be 5. So here's my strategy when I graph these so that I get the best points possible. And this is how I would suggest you do it on Math Excel as well. First thing you want to plot is the center. So you go to negative 2, so left 2, and then up 1, 2, 3, 4. So there's your center. I'll put a red dot for that one. And then, okay, the radius is 5, which means the distance from the center to any point on the circumference of the circle is 5 units. You can't measure diagonally on the coordinate plane with 5 units exactly, so the best thing you can do is go up 5, down 5, left 5, and right 5. I'm just going to go from the red dot up 1, 2, 3, 4, 5, put a dot. Right 1, 2, 3, 4, 5, put a dot. Down 1, 2, 3, 4, 5, put a dot. And left 1, 2, 3, 4, 5. And I've measured it exactly. Every single one of those distances from the red dot to the blue dot is 5 units. That's a radius. Because now when I connect my dots, you know, and if you still have your compass from August, you can do this by setting the gap of your compass to be the distance between the red dot and the blue dot, but feel free to just estimate it like I'm doing. No need for a compass unless you want to be exact. Make it as good as you can. That's not a bad circle. And that's it. You know, if you measure that distance from red dot to blue dot, any distance from red to the green is going to be 5 units. That's it. All right, so this one's backwards. This one, they give you the equation, or they give you the graph of the circle, and you've got to write the equation. So what does that mean? It means you need to make x minus h squared plus y minus k squared equals r squared happen. That's your goal. So what do you need? You need 3 things. You need h, you need k, and you need r. H and k are given to you right away in this circle because that's the center. The circle is centered at 1, negative 3. So right away, I spot my h value and I spot my k value. The trickier part of this one is the radius. And it might look like it's 5 units up and 5 units down, but they didn't give you a dot on the circle to measure that exactly. You have no idea if this circle is just under that level 2 or just over that level 2. So what you got to use is the point that they give you on the circle at 2, 2. So this distance from the red dot to the green center, that's my radius. And there's 2 ways that you can calculate it. You're looking at the distance between 2 points. So you can either use the distance formula to get that radius, or you could make a nice little right triangle. The blue segment's your hypotenuse, and we've done this trick before. Make a little red right triangle out of it. And you can count. This is 1, 2, 3, 4, 5 units. This goes over 1 unit. So I can either use the Pythagorean theorem on this, call this r. So 5 squared plus 1 squared equals r squared. So 25 plus 1 is 26. Okay, so I got r squared. R squared is 26. Or if you don't like that, you can just use the distance formula. You're looking at the distance from 2, 2 to the center, which is at 1, -3. So distance, remember, I'll write the formula to remind you. It's x2 minus x1 squared plus y2 minus y1 squared. So if we label here, here's x1, y1, x2, y2. Subtracting the x coordinates, I get 1 minus 2 squared plus, and then y2 minus y1 would be -3 minus 2 squared. So we get square root of -1 squared plus -5 squared, which would be the square root of 1 plus 25. Remember, those are both positive since I'm squaring something in parentheses. And that's the square root of 26. Okay. So that's my radius, but then the equation needs the radius squared. So r squared would be that radius I found squared, which would just be normal 26. So what's your full equation? They want the equation of the circle. It would be x, and then I change the sign. If I see a positive 1 here, I make this a -1 squared, plus y minus k. K is already negative, so this is going to be y plus 3 squared equals, and then the radius squared, not just the radius, was 26. Whether you get that from here or from here is up to you. You pick whichever approach you like better. So that would be the equation of the circle they have graphed. And you'll notice in these examples we're doing here, whenever we're writing the equation, we're not plugging in anything from x and y. X and y would be any points on the circumference of the circle, but we're just trying to keep it general when we write the equation. But x and y would be any points that lie on that circumference. So speaking of x and y, we're going to need that in this one. Write the equation of a circle with a center at -1, 6 that passes through the point 4, -2. Passes through means it's on the circumference. That's not the center that they're giving you. What they're trying to tell you is you have a circle with a center at -1, 6, and this point 4, -2 is on the circle. It's passing through the circle. Okay? So that little value they give you right there is an xy value. This one they're giving you in the middle is h and k. That's the center. So how are we going to figure this out? The only thing that's missing is the radius. They already gave you h. They already gave you k. You can use that point on the circle to get the radius because it's just the distance from the center to that point is r. So I'm just going to set up what I know. I know my equation so far is going to be x, and then, let's see, it passes through, or centers at -1, 6. So I'm going to make that +1 squared plus y minus 6, change the sign on the center, equals, they didn't tell us a radius, so we're just going to leave this as r squared for right now. But I can plug in for x and y now because I know a point that's on the circumference of the circle. 4, -2 is my xy value I can use to plug in. And that's going to help me solve for r. So what's x? X is 4. I got 4 plus 1 squared plus y is -2 minus my k value is 6. And notice I'm only changing the sign on h and k. I'm not changing the sign on the x and the y because there's no negative in front of them. Equals r squared. And all I need to get is r squared because that's what's in my original equation. So I get 5 squared plus -8 squared equals r squared. So 25 plus 64 is r squared, which means that r squared is equal to 89. And you don't even need to square root it because it's not r that's in the equation, it's r squared. So at this point, I just write the equation. I would have x plus 1 squared plus y minus 6 squared, my pen is lagging, sorry, equals 89. That's my r squared value that I needed. All right. I'm going to clear the ink from this page, so if you still need something, pause my screen, write down what you need, and then as I get to the bottom one here, I'm going to clear the ink so that it doesn't lag. And have a look at the iPhone joke before you move on. Give yourself a laugh. Maybe you're looking for the latest model of iPhone. iPhone x minus h squared plus y minus k squared equals r squared. Ha ha ha. Okay. All right, so last type of problem we're going to look at is, what if they give you the endpoints of the diameter? They don't give you a center, they don't give you a radius. All they tell you is what the two endpoints of the circle are, and you do know it's a diameter. So we can still figure out the equation of the circle with that piece of information. Okay, what you got to remember about a diameter is it passes through the center. So if I have a circle, diameter is a special type of chord that passes through the center of the circle. So in this problem, they're telling me that the diameter has endpoints at 3, 0, and 7, 6. I'm just going to plot those on the coordinate plane first. One of them's at 3, 0, and one of them's at 4, 5, 6, 7, 1, 2, 3, 4, 5, 7, 6. Okay. So you got to keep in mind, that's the endpoints of your circle. Your center is going to be somewhere in between those blue dots. And it's exactly halfway in between because a diameter is made up of 2 radii. The distance from this blue dot, let's just say this is A and this is B. The distance from A to the center is the same distance as B to the center. Those are both radii. So what I need in order to get the center, I need to get the midpoint of A and B since it's halfway in between. So I'm just going to call this center M. And so to get the midpoint, what you got to remember is you've got to add up your x values and divide by 2. And you've got to add up your y values and divide by 2. You're just averaging the x's and averaging the y's. So if I add my x's, 3 plus 7 over 2. And if I add my y's, 0 plus 6 over 2. The center of that circle is going to be at 5, 3. And so I'm going to plot that. 1, 2, 3, 4, 5, 1, 2. That's exactly halfway in between. This is a radius, and this is a radius. Tick, tick. Now, we still don't know what the length of that radius is, though. I need to figure out what that radius is before I write the equation. So the radius, use your distance formula, or you can make a right triangle out of it. I'm going to do the distance formula for this one. And what I'm going to do is I'm going to measure from the red dot to either one of the blue dots. These are both the same length, so it really doesn't matter which one you use. To me, this one looks easier since it's got a 0 involved. So I'm going to find the distance from 3, 0 to 5, 3. So if I plug in, 5 minus 3 squared would be x2 minus x1 squared, plus the distance between the y coordinates would be 3 minus 0 squared. So the one I'm finding right now, let me just highlight so you can see it in the picture. I'm measuring this distance right here from the red dot to the blue dot. So this would be, and I'm not going to use D. D is confusing. Let's use R for radius. So 5 minus 3 is 2. So this would be 2 squared. And then 3 minus 0 is 3. So plus 3 squared. This would be the square root of 4 plus 9 is 13. Now, that's the radius. Okay. Now, square root of 13, obviously, you're not going to be able to graph this one super exactly. You'd be going up, down, left, and right about 3.6 units. You can estimate the circle. If you want to draw it, you can. 2, 3, about here, about here, about here, and then about here. You know, it's not going to be an exact circle, but that at least gives you a visual for what's going on in the picture. So now I get the equation. What do I need? I need the center, I need h and k, and I need the radius. The center we figured out in part A. Here was h, here was k, 5, 3. And the radius we got was rad 13. So putting it all together, I'm going to get x minus 5 squared, because I got to switch the sign, plus y minus 3 squared, because I got to switch the sign. And remember, I'm not going to put rad 13 here. I'm going to square the radius. If you square the square root of 13, you just get normal 13. That's it. That would be the equation of my circle. So to summarize what we did in this problem, the first thing we did is we used the midpoint formula to get the center. And then once we had the center, we used the distance formula to get the distance between the center and either one of those blue dots, A or B. So in the picture, let me label for you. This was A. This was M, which is what I called my center. This was B. MA or MB, didn't matter which one you use. Either one of those is a radius. And you use the distance formula, or you can draw one of those little right triangles and use Pythagorean theorem if you would like to instead. So why don't you try one out? It's pretty much the same approach that I just did. Okay, give this one a shot on your own. Pause my video, and then once you're done, I'll put up a solution and you can check with what I have. Okay, so if you've already finished this one, they give you the diameter of a circle has endpoints at 5, 0. So I'm going to draw that. And -1, 8. Okay. And so like we saw in the last one, the center of that circle is going to have to be somewhere in between those blue dots. If I was to draw a diagonal line, the center would be halfway in between. So the first thing I'm going to do to get the center, I'll call it C this time for center, is I'm going to use the midpoint formula. X1, Y1, X2, Y2. I'm going to average the X's and average the Y's. So 5 plus -1 would be 5 minus 1 over 2. 0 plus 8 divided by 2. So my center is going to be at 2, 4. I'm going to draw that. And so again, this is a radius, and this is a radius, because I'm going from the center in red to a point on the circumference of the circle, which is going to be on those blue dots. Okay. So now if I find the radius, before I draw the full circle, I'm going to calculate that radius, that distance. So the distance from 2, 4, you can take your pick. You can either go to this one, or you can go to this one. I think A looks easier because it has a 0 involved, which always makes life easier. And this was what, C? So I'm going to do, I'll do distance formula again instead of making the triangle. So x2 minus x1 squared, different labels this time though. So this would be my x2 and my x1. So 2 minus 5 squared plus, and then y2 this time is 4. 4 minus 0 squared, which would be the square root of -3 squared plus 4 squared. 9 plus 16, b squared of 25, which is 5. And again, I'm going to use r. I don't know why I keep doing d. R for radius. So the radius is 5. So if you want to really make a nice exact graph of the circle, go to the center, go up 5. 1, 2, 3, 4, 5. Go right 5. 1, 2, 3, 4, 5. Go down 5. 1, 2, 3, 4, 5. Oh no, which direction did I forget? Which direction did I forget? To the left. 1, 2, 3, 4, 5. To the left, to the left. I'm done. And it should go through your blue dot also, because we said that was on the circle. Don't need to be a perfect circle drawer, just do your best. Okay, so there's my circle. And I know these two distances were equal. So now I put it all together. Using the standard form of my circle, I switch the sign on h and k. Here was h, here was k. Get x minus 2 squared plus y minus 4 squared equals, what should I put there? Not 5, I should put 5 squared. R squared is 25. That's it. All right, last one we want to take a look at. It says, is the point -10, 30 located on the circle, inside the circle, or outside the circle that has the equation x plus 15 squared plus y minus 35 squared equals 102? They didn't really give you a picture for this. You kind of have to think about your own picture. Let's just draw a circle. Right away, I know that the center of this circle is at -15, +35, because I got to switch the h and k value when I write the center. So you don't need the whole coordinate plane to do this. Just want to give you a visual for what's going on. Here's my center. Let's call that C. Okay. And then they tell you there's this point, -10, 30, and it might be on the circle. If it's on the circle, they mean on the circumference, would mean on the blue that I have drawn around the circle. On the circumference. If it's inside the circle, it's inside the blue, and if it's outside the circle, it's outside the blue. How do you decide where that dot is at? The way you decide is you compare it to how long the radius is. You know that the radius is going to have a distance that's, every single point that's a radius away is on the circle. So if -10, 30 is on the circle, it should have the same distance as the radius of this equation. So maybe -10, 30 is on the circle, in which case it would have the distance of the radius. If -10, 30 is inside the circle, think about it, would that be smaller than the radius of the circle or bigger? Well, since it doesn't even touch the circle, that would be less than the radius of the circle. That would be if -10, 30 was inside. And what if -10, 30 was out here? Well, now, from here to here, boom, that's a radius. So if I keep going, now I've gone beyond a radius. This green segment is greater than r. So the first thing you got to figure out is what the heck is r? The radius of this equation is the square root of 102, because that's r squared. Square root of 102, it's about 10.09. So what you got to do is you got to figure out the distance from the center to this point. We're just going to call it xy. Distance formula. So I've got to look at the distance from the center in red, -15, 30, to the green dot, which they told me was -10, 30. I'm sorry, this is 35. There we go. So I'm just going to do a little distance formula on this. x1, y1, x2, y2. I'm going to get x2 minus x1 squared will be -10 minus -15 will be +15 squared. Plus y2 minus y1 squared is 30 minus 35 squared. So I get 5 squared plus -5 squared. 25 plus 25 would be the square root of 50. And the square root of 50 is about 7.07. Okay, so here's what you got to do. You got to compare it now. The radius was about 10.09 units, and the distance from the center to this dot they gave us is only 7 units. So it doesn't quite reach the blue circumference of the circle. So which situation are we in? We're in this situation right here. This dot is less than the radius. So I am inside the circle. So all I'm doing is comparing the distance between those two dots to the distance of the radius and deciding if it's equal to the radius, bigger than the radius, or smaller than the radius. And that helps me decide where that dot is in relation to the circumference of the circle. All right, that should do it for section 12.5. Your Math Excel is up and posted. Have some fun on the coordinate plane.